Hello friends, welcome to the first problem of Turing machine. Now if you observe the question over here says design a Turing machine to recognize the following language, and the language is L is equal to A raised to n B raised to n where n's value is greater than equal to 1. Now friends, if you observe this problem, this is ditto same to the first problem on push down automata. And that's exactly what we are trying to figure out over here as to how a PDA problem can be solved using Turing machine. And then in the second problem, or from the second problem itself, we can start exploring the actual problems on Turing machine too. Though in the exam, this is one of the very popularly asked problem. So my recommendation is not to ignore this and understand it for understanding the depth of the problem. Later on, as I always do, I'll be only solving the main heart of the problem and not solving all the steps. So therefore, for the first problem, we have the entire thing solved, and later on, we'll be having only the main part of it solved. So let's get started with the problem. So friends, for this question, L is equal to A raised to n B raised to n. For solving it, my step number 1 as usual is going to be the theory of the Turing machine. The theory is something that we discussed till now. Anything of it which you think is good enough for writing 1 marks, you can write it over here, because this problem will be coming as a 10-mark problem in the exam, right? So you can just write a gist of whatever we have studied over here. Maybe what is Turing machine and its two features should be more than sufficient over here. Going ahead to my step 2. My step 2 is going to be the logic. Now, as far as the logic is concerned, I would highly recommend that you consider some value of input. Maybe over here, I am considering the n's value as 4 in the problem. So if n's value is 4, the input is going to be A followed by B followed by a lot of blanks on the left and right side of it. We are not concerned with that as of now. We are interested in formulating the logic for it. So let's try to understand the logic. So friends, the logic over here says I am always going to start from the first input symbol. So I say the moment in the start state, if you are getting a input symbol like A, you make it as X and move to the right. Now when you move to the right, you get another A, you bypass it, go ahead. You get another A, bypass it, go ahead. You get further A, bypass it, go ahead. This bypassing of the A and going ahead is going to go on and on till you get the first B. The moment you get the first B, you are going to make it as Y and take left turn. So once you take a left turn after making the first B as Y, you are going to have small a as the input. So now when you get a small a, you are going to keep it as A and move to the left. Another time you get a small a, keep it as A and move to the left. Now this bypassing of the A's is going to go on and on till you get the first X. Yes, till you get the first X which you just converted. And the moment you get the X, you are going to keep the X as it is and move to the right. So now when you keep this X as it is and move to the right, you will be getting another small a. Now you are set to repeat the logic. The moment you get another small a, you are going to convert it to X and move to the right. You are going to bypass all the A's, and after bypassing all the A's, you were expecting a B. But now you will be getting a Y also on the way. Let it come. Bypass that also. So I bypass the Y, and if to the right of the Y I am getting a B, I am going to make it as Y and move to the left. Now to the left of this capital Y, I get another capital Y. Bypass it. Further 2 A's, bypass it. Keep on bypassing everything till you get the first capital X. I'm talking of the first capital X. And the moment you get the first capital X, keep the capital X as capital X and move to the right. And now you will be getting another A. Keep that A and modify it to X. Move to the right. Bypass everything till you get the first small b. The moment you get it, make it as y and move to the left. Bypass everything till you get the first capital X. Keep capital X as it is and move to the right. If to the right of capital X you get a, make it as X, bypass everything, move to the right till you get the first small b. The moment you get the first small b, you make it as Y, move to the left. Now we are almost at the end of the problem. Now, when you are moving to the left of the latest modified Y, you get a lot of Y's. We are going to bypass all of them till you get the first X. Now, when you get the first X, you are going to keep the first X as it is and move to the right. Now guys, up till now, whenever we were moving to the left in the search of first X, and after getting a X, we used to keep the X as it is and move to the right, we were compulsorily getting a A. But my friends, now we are not getting a A over here. We are getting a Y over here. That clearly signifies that my A's have been exhausted. But that does not necessarily mean that B's are also exhausted. So, since A's are exhausted over here, I have to check whether B's are also exhausted. And how can I check that? Initially bypass all the Y's, and if to the right of the Y I do not get a small b but instead I get a blank, I can conclude at that point itself that the input has to be accepted. So over here, when I'm standing at this particular arrow, I bypass the first Y, second Y, third Y, fourth Y, and to the right of this I see that there is a blank. I say keep the blank as it is and say that the input is going to be accepted by my Turing machine. That's how simple it is going to be. Let's consider the vice versa case also. That is the case of the reject examples. I can also have an input like A followed by two B's and some blanks on both the sides. First A will be made as X, first B will be made as Y. Second A would be made as X, second B would be made as Y. Third A would be made as X, and bypassing everything I go to bypass A, bypass capital Y's, and after capital Y's I was always expecting a small b because I got a small a which I converted to X, and here instead of getting a small b I got a blank, and since there is a blank over here, my Turing machine is going to reject such a type of input because it did not receive a corresponding small b for a small a. Similarly, let's consider one more example. The input is A, B, B, B blank. Over here I say for first A make it as X, first B make it as Y. First A make it as X, first B make it as Y. Now when I go to the right of capital X, I get a capital Y, signifying that all of my A's are over. So now naturally all of my B's should also be over. That is, to the right of all the capital Y's, I should compulsorily get a blank. So now when I move to the right of all the Y's, instead of getting a blank, I see that I am getting a small b over here, and here comes a reject for such a type of string. And this guarantees that using this logic, my machine is going to accept or reject the inputs perfectly. So having understood this, let's go to the implementation function of this to understand how it can be implemented. Implementing the same logic over here in my step 3. So I am going to start from my state Q0 as the start state. So in Q0, as I told you, I'm standing over here. In Q0, when I receive a I'm going to make it as X and move to the right. So in Q0, I am going to receive a input symbol A. I'll be making it as X, comma R means move to the right. Fine. Now when I move to the right, I am in state Q1, and in state Q1 I see I am getting a A. As you know, we have to bypass that A. For bypassing, I say I get a, keep it as A and move to the right. Again when I move to the right, I get another A. Using the same cyclic transition, I say Q1 on A when make it as A only and move to the right, or rather we can say keep it as A and move to the right. Now this moving to the right is going to continue till I get the first small b. Over here in Q1, the moment you get a small b, you are going to make it as y and move to the left. So in Q1, the moment you get a small b, you are going to make it as y and move to the left, right? Now when you move to the left, you are going to get a lot of a's. So I say whenever you get a, you keep it as a and move to the left. So you bypass the first a, second a, and this bypassing and moving to the left is going to go on and on till you get the first x, right? And the moment you get the first x, you are going to keep that x as it is and move to the right. So I say in Q2 state, the moment you get the first x, which is over here, keep it as x and move to the right. So now you are over here. Again you will be getting the first a, and now you can see that this diagram can be reused by us. I am in state Q0, input symbol is a, make it as x and move to the right. I am in Q1, input symbol is a, keep it as a and move to the right, and now I get y for the first time. So what will happen if in state Q1 I receive a y? I have to bypass it. Therefore I say if in Q1 I get a y, keep it as y and move to the right. And now to the right of y in Q1, if I get a b, I'm going to make it as y and move to the left. Now when I move to the left, I'm in state Q2. In state Q2, I am getting capital Y for the first time. So let's include that transition. In Q2, if you get a capital Y, keep it as capital Y and move to the left. Next you get a small a, keep it a small a and move to the left. Next you get a capital X, keep it as capital X, move to the right and go to state Q0, right? Now after 2 iterations, you will find that my diagram is complete, and the third iteration is simply meant for verification of this. So let's verify the things. In Q0 state, on receiving an input symbol A, you make it as X and move to the right to Q1. In Q1, for all the Y's, you are going to bypass it and move to the right. For all the A's, you are going to bypass it and move to the right. So we don't find any A's over here, but all the Y's in Q1 will be bypassed. And in Q1, when you get a small b, you are going to turn it to capital Y and move to the left. Now when you move to the left, instead Q1, you get a lot of Y's which will be bypassed, and you don't get any A's over here, but directly you are getting a X. And Q2 on receiving capital X goes to Q0 by keeping X as it is and moving to the right. So now X, keeping it as X and moving to the right, takes me to the first Y as a circled over here. Now this is for the first time in the history of this Turing machine that in state Q0 I am getting an input symbol capital Y, and Q0 is not capable of handling it. Therefore, we say we have to write a new state. What will happen if in state Q0 I get a Y? I say for the first Y at least, remember this, for the first Y at least, keep it as Y and move to the right, and we go to a new state over here called as Q3. So I am right now on second Y. I say what operation you did on the previous Y, perform the same thing on all of the remaining Ys. That is, in Q3, for all of the Ys, keep it as Y and keep on moving to the right. Y will remain as Y, move to the right. Y will remain as Y, move to the right. And after moving to the right again in state Q0, if I get a blank, that signifies that my A's and B's have exhausted proportionately and the language belongs to the form A raised to n, B raised to n. Therefore, Q3 on receiving a blank, keep it as blank and do not move to the right or left. Therefore, we say remain stationary. We write S over here and I say go to the final state QF over here and accept the input. So that's how the Turing machine can be designed for this. As far as the Turing machine problems are considered, we are always going to draw the transition diagram or the transition graph first, and then we are going to draw with the transition table. So my step 3 does cover the implementation part. In the step 4, we are going to draw the transition table for the same. So let's go ahead with the same. So my step 4, which is going to be my transition table, I have over here Q cross G with the states as Q0, Q1, Q2, Q3, QF, input symbols as A, B, X, Y, blank. Okay. Now, moving on to the diagram, I see that Q0 on A goes to Q1 by making A as X and move to the right. Therefore, we say this transition would be written as Q1 comma X comma R. That's how easy it is to represent. How do we write? Q0 goes to Q1 when the input was A by making it as X and moving to the right. Let's go ahead and see, does Q0 ever receive a B? No. Does Q0 ever receive a capital X? No. So, my second cell and third cell will always be blank, signifying no operations. Going ahead, does Q0 receive a Y? Let me check that. Yes, Q0 does receive a Y, and in that case, it keeps the Y as Y, moves to the right to state Q3. So let's write it. It goes to state Q3, keeps Y as Y and moves to the right. Similarly, does Q0 receive a blank? looking at the diagram, I see that Q0 never receives a blank. So for Q0 state, at least the entire row is done. Let's go ahead to Q1 now. Q1 receives a and goes to Q1 itself by making A as A again and moving to the right. So we write Q1 comma A comma R. Similarly, Q1 also does receive a small b, and it says Q1 on B makes it as Y, moves to the left to state Q2. So we have Q2 comma X comma L over here. Q1 does not receive capital X, but Q1 does receive a capital Y by keeping the Y as Y and moving to the right to the state Q1 again. So let's write it. So we have Q1 comma Y comma R over here. Next, Q1 does not receive a capital blank, so we are not concerned with that, and therefore Q1 row is now done. Similarly, going on to Q2. So for Q2 also, I see that I do have a transitions for input symbol small a. I have transitions for input symbol capital X and capital Y. So let me fill that very quickly. So I have over here Q2 comma A moves to left. I have over here Q0 comma X moves to right. I have over here Q2 comma Y moves to left. Similarly, for Q3, we see that the input can either be capital Y or it can be a blank for the first time. So let's fill for capital Y first. Q3 on Y remains in Q3 by making Y as Y again and moving to the right. Therefore, we say it goes to state Q3 again, keeping Y as Y and moving to the right. And for blank, Q3 on blank will keep it as blank, will not move the read head anywhere but go to the final state. So we have QF comma blank comma S. Lastly, for QF, does QF go out anywhere? No. So the entire row is going to be empty. So we can simply write it over here as, since it is the final state, it is not going to show anything and we are done with the transition table. So that's how easy it is to represent. So as far as the Turing machine is concerned, what is important is drawing of the transition diagram. Transition table follows it. So this is for the first time that we are doing reverse engineering over here. So having understood this, the last step which is left is of course solving of the examples. Now in Turing machine, we have already solved the examples. There is nothing as such to be shown over here as to how to solve the example. But still, maybe out of curiosity, you may want to show onto the paper how to solve an example. Then you can also go ahead in the manner which I will be showing you just right now. So friends, let us assume that you are interested in solving an example. So that's my step 5 over here. And for example, you have to show a tape over here. And let's consider the input to be A, B, B and a blank. So how do you solve it? We say currently you are over here in state Q0. That's how you have to write it. Every time I erase the diagram, you have to redraw it in the paper, right? So in Q0, when you receive a you are going to make it as X and move to the right and you go to the state Q1. In Q1, when you receive a you are going to keep it as A and move to the right and remain in Q1. In Q1, when you receive a B, you are going to make it as Y, move to the left and go to the state Q2. In Q2, when you receive a you are going to keep it as A, move to the left and go to the state Q2 again. In Q2, when you receive a X, you are going to keep it as X, move to the right and go to state Q0, right? So, till now, the first iteration is done. Thereafter, further I say Q0 on receiving a you are going to make it as X, move to the right and go to state Q1. Q1 on Y, you are going to keep it as Y, move to the right to state Q1 again. Q1 on receiving a B is going to make it as Y and go to the left to a state Q2. Q2 on Y will keep it as Y and move to the left to state Q2. Q2 on X will keep it as X and move to the right to state Q0. And now in state Q0, when you receive a Y for the first time, it will keep it as Y, move to the right to state Q3. In Q3, for all of the Y's, it will keep it as Y and move to the right and remain in Q3. However, if in state Q3 I am receiving a blank over here as I saw over here, I will remain in blank as blank. Do not change the state, but I will go to the final state and I'll keep the blank as it is. And with this, we can say that the input will be accepted by the machine. So friends, over here, every time you are showing the transition, unless and until a scribbling is there, you can keep on reusing the same diagram in the example. However, the moment we realize that a scribbling is happening, you have to redraw the diagram below that and start explaining the example continued from that point. So that is one way you can actually show the working of the Turing machine with the help of example. Although it's not recommended to be written in the exam, it's not mandatory. So as far as Turing machine problems are considered, first 4 steps should be sufficient for solving it. So with this, we complete with the first problem on Turing machine. See you in the next problem, and don't forget, from the next problem we will be drawing only the logic and the implementation part. Rest all things, I assume that you should be able to do it on your own. See you in the next session. Thank you.